Let us take a moment to look closer at how data is processed to create terrain elements. By developing an understanding of how triangulation is accomplished, you will be better prepared to understand the capabilities and, more importantly, the limitations of these formats. In the previous video, we learned that DTMs, TINs, and terrains all adhere to the same mathematical principles. But what are these principles? How are they applied to create terrains? And what do these processes teach us about terrain data? These formats all rely on the work of a Russian mathematician and mountain climber named Boris Delaunay. In 1934, Delaunay published an important paper that outlines a method for defining a set of interconnected triangles from a set of points. This method is commonly referred to as Delaunay's triangulation. In general, this approach has the following properties. Triangles are formed by connecting the three nearest points with no segments intersecting. No points shall exist inside the circumcircle of any triangle. Regardless of the starting point, the results will be consistent. And triangles with the shortest sides are favored over the long, skinny triangles. The foundational principle that no points shall exist inside the circumcircle of any triangle means that when a terrain element is created, every point must be evaluated against every triangle that is drawn. You may remember from geometry that a circumcircle is any circle that passes through all vertices of a polygon. While not all polygons will have a circumcircle, all triangles will have one, and there are several ways to determine the radius. Exactly how this is accomplished in the software is not critical, but if I find the distance to visualize the process, and this concept is new to you, from both points that is just slightly longer than 1/2 the distance, we will get two arcs that share two intersection points. These points will form a line when connected. If we then follow the same process for either one of the two remaining sides, and then extend the lines to a common intersection, we will have found the circumcenter or center point of the circumcircle. Delaunay's method calculates these circles to see if any additional points fall within the circle. If a point is found to exist within the circumcircle, then these triangles will be removed and new triangles will be formed that now connect to this new point.